different options are there. We are having multiple options in that. What are the multiple options, miss? First option is called as filter methods. The first option is called as filter methods. Second option is called as wrapper methods. Third one is called as embedded methods. Embedded methods. Okay, filter methods, wrapper methods, embedded methods. 3 of them are there. Okay, we are having 3 different types of methods: filter, wrapper, and embedded. Now let us understand each of the methods clearly. Now, what is meant by filter methods? Okay, so filter methods, heading as filter methods. Now in the filter methods, by using these methods, we identify the unimportant variables. We identify the unimportant variables by using statistical analysis. Okay, by using statistical analysis. Now, what is meant by statistical analysis? We are going to remove the unimportant variables by using the statistical analysis. What are the different statistical analysis are available? Means the first statistical analysis we are having is called as correlation. The first one is correlation. So whichever the variable is less correlated to the output variable, that we are going to remove. Okay, which is having a low correlation coefficient. So we are going to identify the unimportant variable which is having, so unimportant variable which has low correlation coefficient, which has the low correlation coefficient, that is the unimportant variable. Low correlation coefficient with output variable. With output variable which is having a low correlation, that is not important and you can remove that one. So which is having a very low correlation, you can remove that. Second one, low variance. If the particular variable is having the low variance, you can remove. Okay, which is having a very low variance. There is no changes. There is no difference. For example, 1, 1.1, 1.1, 1, 1.1, 1, 1.1, something you're having a data like this. This column, if there is no of this column, and if you do the modeling also, you'll get the same answer. By removing this one also, still you will get the same answer. If you apply any algorithm, whatever the algorithm you want, you can try. For example, we have applied the TV, radio, newspaper column. For that, what you do is you create one more column. In that column, you keep all of them as ones only. Everything is 1. Whatever the number of records are there, everything 1, 1, 1, 1, 1, 1. Just to only 1. Only 1 is there, means what is the meaning? Means the variance is equal to 0. There is no difference now. Mean value will be 1. That difference also will be 0. And the square of that one will be 0. Sum of that will be 0. Everything will be 0. Means the variance is going to be 0. Variance will be 0 and standard deviation is equal to 0. So now for that particular column, what happens means if you consider that column also, still you get the accuracy same. If you remove that one also, you'll get the accuracy same. There'll be no difference. So which is having a very low correlation or very low variance, you can remove that. Okay, that is the reason any constant variable is there. Any constant variable that is having with a constant value, a variable with a constant value, just you can remove. A variable with constant value. With a constant value, one and only value is that, means simply remove. Simply remove the variable which has the constant value. There is no use. Simply you can remove. Because the variance is going to be 0. If there is no variance, for example, I'm having the male data. I'm having everything male, 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 male. Everything are male only. There is no female only. Then what is the use of doing the analysis? If males and are there and females are there, means what is the average of the males we are going to see? What is the average of females we are going to see? And from that we are going to understand something. If only male data is there, then what you are going to analyze? So a constant variance, there will be no difference. And you can remove that one. Means a variance which is having a low variance, completely low variance, that you can remove. So this variance concept and correlation concept, these both we have discussed in the descriptive statistics. So by using the statistical analysis, we can remove this one. Now, if you observe this one, a low correlation coefficient with the output variable, which is having a low correlation or low variance. And if, for example, all the unique values, a column which is having a constant value or unique value, same value, it is called as low variance. Now, if, for example, if a variable consists of multiple records, means multiple values, that one also you can remove. Means each record is a different value also you can remove, because serial numbers are there. Some serial number will be there. The serial number, there will be no use. That we can remove. Okay, so that we are going to remove. Like name, there will be no use of the name, because every record the name will be different. That one also we can remove. So like this, we are going to identify some of the variables based on the common sense. Some variables we have to identify based on the common sense. We have to say, sir, this variable is not important based on the common sense. Okay, commonly we'll identify, is your father name is having any relation with your CGPA, predicting the CGPA? No. For predicting the CGPA, your father name, your mother name, your date of birth, or was nothing is important. For predicting the CGPA, how much time you have spent for learning, that is important. How much skill you are having, that is important. For predicting the salary of a data scientist, for that one also, name is not important. If the name is Mahesh Babu, means he'll not get more salary. If his name is Suresh, means he'll not get less salary. Any name, irrespective of the name, they'll give the salary. Okay, it is not dependent on the name. So just we can remove the name column for predicting the data scientist salary. For predicting the whether the person is having a diabetic or not. For predicting the diabetic, serial number is not important. Serial number is the row number. Serial number is not important. Serial number we can remove. For that, simple common sense is sufficient. If serial number is having any relation with the diabetic, means if you visit to the hospital by 100th patient, means you'll have the diabetic. If you have visited the hospital as 120th patient, means you'll not have the diabetic. Is there anything like that? So it is a common sense. So we are going to remove some of the variables by using the common sense, right? Now, so basically we remove the sum of the variables based on the common sense or based on the statistical, like correlation or low variance, like this. If you observe this one and this one, both of them for continuous only, for continuous variable. Correlation is applicable for continuous variable, and variance also applicable for continuous variable. We can't apply for the discrete variable this logic. Then how we can apply for the discrete variable the logic for the discrete variable? Means how we can check the discrete variable. What are the discrete variable we are having? That is, we can do like entropy by calculating entropy or information gain of each column. Discrete variable, which is of discrete variable. For that, you calculate the entropy or information gain. And based on that, which is having the low information gain, remove that one. Okay, which is having a low information gain, you can remove, right? So these both are continuous variable. This is for the discrete variable. So these all of them will be done before to the modeling. The entire filter methods, whatever the filter methods are there, this entire filter methods will be done before modeling itself. Before applying the modeling itself, you are going to do this one. Okay, so how we are going to remove? So how we are going to remove is basically based on the statistical analysis. We can't remove the variable of our choice. We have to prove why we are removing this one by showing that this is particularly, it is not useful, and we are going to remove that one. right? So that is before modeling. This entire filter methods are applied before the modeling. Now, next one is there. Next type of method is called as embedded method. Next, this is filter method. Next one is called as embedded methods. Embedded methods means this can be done only after modeling. Means first you have to complete the modeling, then only you can identify the important features. This can be done after the modeling. You can't do before to the modeling. Before to modeling, you can't apply this logic. You have to apply only after the modeling. So what are the different options of embedded methods are there? Means option number one in the embedded methods. Within the embedded methods, option number one. We are going to check in terms of whether the variables are significant in linear regression. Variables are significant in linear regression. If you are applying linear regression means we are going to check whether the variables are significant or not. Right? The p-value. If the p-value is greater than 0.05 means we are going to remove that particular variable. Right? Now, second one, lasso. By using the lasso regression. In the lasso regression also, we are going to get some of the quotients are going to be 0. Some beta values are going to be 0. For which variable the beta value is going to be 0, remove that particular variable in lasso regression. Okay. After applying the lasso only you can see the beta values. Before applying the lasso, how you can see the beta values? Without applying lasso, you can't see the beta values, right? After applying the lasso only, you can observe the coefficients, whatever the coefficients are there. For whichever the variable, the quotient is equal to 0, remove that particular variable. Next, third one is some random forest, that is bagging technique. Bagging technique or decision tree bagging techniques. From this also, you are going to identify which are the future importances. Model dot future underscore importances underscore. You are going to write that one, right? That you can write only after the modeling. That you can't write the before the modeling. Only after the modeling only it can be. So bagging technique or decision tree or with respect to boosting. In the boosting also, in this both of them, you are going to see the future importances. Future underscore importances, and whichever the futures are unimportant, you are going to drop that one. And I have shown you an example with the Penguin data set where the body mass is not important a variable. At the same time, in the boosting techniques, I have shown you out of 95 variables, I have removed almost 80 variables which are not having the importance. Do you remember, guys? So we are identifying the future importances only after the modeling. If you are able to identify the future importances after the modeling, they are called as embedded methods. Before to the modeling, if you are identify which are the important features, which are unimportant features, then it is called as with respect to filter methods. In the filter methods, we can even have this collinearity also. If there is a collinearity problem, we are going to drop one of the variable. Collinearity also comes under filter methods. That also we are going to apply before only, because the correlation matrix we are going to observe, and between the independent and independent variable, if there is a high correlation, we are going to drop one of the variable. But which variable has to be dropped means that we are going to see the VIF score. Means that is after the modeling only. We can do only after the modeling. After the modeling only, you can apply this one. So collinearity doesn't comes under filter methods. Though you are applying the correlation also, you are able to see the correlation also. There is two independent variables, correlation is very high. You have observed that one. There is a collinearity. Observation only you can do. But which variable has to be removed? Two variables. Out of two variables, one has to be removed. Which one has to be removed? Which one has to be removed means which is having the highest VIF. VIF has to be calculated means after the model only. Na? First, you have to design the model, and from the model, you have to calculate the R square. And after create R square, you have to calculate the VIF. VIF is equal to 1 divided by 1 minus R square. So you can calculate the only after this. You can't do this collinearity in the filter methods. Collinearity also comes under embedded methods. Why collinearity also comes under embedded methods means because after the modeling only you can observe which p value is high. And if you observe that one, If whichever the p-values are high, that you are going to identify and you are going to calculate separately VAF value, and from the VAF value which is having the highest VAF, you are going to remove. So these all comes under embedded methods. Whichever you are doing after the modeling is called as embedded. So in 99.9999% of the cases in the real life, we are going to apply the filter methods followed by embedded methods. These two methods will apply. First, we'll try with the filter methods. Opening itself, first we'll load the data. In the data, if you are having any serial number or name columns or something is there, first we'll drop based on the common sense. First step, we'll do that one. Okay, these columns are not required. Basic only we'll understand. Some columns we can understand by seeing itself. Okay, that is common sense. After that, what we are going to do is we are going to do the EDA. When we are going to do the EDA, in the EDA, correlation matrix also is one of the part. Correlation is one of the part. Describe function is also one of the. So when we are going to apply the describe function for the continuous variable, within the describe function, the standard deviation will be there. First count, mean, standard deviation, minimum value, 25, 50, 75, and maximum. These are the things which you are going to get in the describe function. Now, within the describe function, for each column, you are going to see the standard deviation. And which is having a very low standard deviation. Standard deviation is low means automatically variance is low. So which is having a very low standard deviation, that particular column you are going to drop. Okay, if it is not having that much of variation. Sir, standard deviation, how much below, sir? Some value. What is the value? Can you say exactly the value means? Whichever the standard deviation is less than 1. Less than standard deviation 1 means variance also will be less than 1 only. So variance is less than 1 means there is no variance only. If there is no variance means that column is not useful. Simply you can drop. Right? Correlation coefficient in terms of with the output variable, whichever is having a very low correlation coefficient like 0.3, less than 0.3, everything you can drop. Sir, for example, a correlation of 0.35 is there, sir. Okay, with the output variable, input and output variable is having a correlation coefficient of 0.35. Now, should I drop or should I not to drop? Just you keep that one. And in the embedded methods, after embedding, once the model was completed, model only will tell that it's not important. Later you can remove if it is in that case. If you are having any doubt, 50-50 dilemma or something you are having a doubt means, keep that variable, don't remove. And after the model, automatically identify the future importance. Future importance, that particular variable, see how much importance it is having. If it is having a very low importance, automatically the meaning is you have to remove only, right? Is that clear, guys? So in this way, we are going to have the filter methods and embedded methods. And the last one, so now if you observe this filter methods, correlation coefficient, I have told you during the EDA, and how to calculate the correlation, I have told you in the statistics. And variance, this also I have told you in the statistics. And entropy or information gain. Recently, when we have completed this decision tree, I have explained you what is meant by entropy or information gain recently, right? Without, for example, I have not completed the decision tree. I have not completed the decision tree. I have not completed the random forest, or I have not completed this everything. Generally, if I explain this one at the starting itself, before to the classification algorithms, before itself, I have explained how I have to explain this point and how I have to explain these points. That is in the embedded methods, bagging technique or boosting technique, and using the future importances, you don't know at that time. Now you know, because we have completed this one, what is the meaning of future importances and how the model will identify the future importance also, you know. Because in the decision tree, I have shown you how much any particular variable was not used for decision node means that particular variable is given as 0 priority. Not even one time it is using. Not even one time it is using for making the decision. This particular variable is not used for me to make a decision. For example, in my company, I'm having 10 people are there. Out of 10 people, when I want to discuss something, I'm calling 9 people. To take a decision, I'm calling 9 people. I'm discussing with 9 people and I'm taking the final decision. To one person, I'm not discussing. With that particular person, I'm not discussing. I'm not taking any decision based on his suggestion. But remaining 9 people suggestions, I'm considering. 1% suggestion, I'm not considering. Now, what is the importance I'm giving for that particular person? 0%. I'm not taking any suggestion from him. Though he is giving a suggestions also, I'm simply ignoring his suggestions. I'm not giving any importance for him. 0 importance I'm giving. So the same thing in the decision tree, in the rectangular box, that is decision node. In the decision node, that particular variable is not considered, means it is not having any importance. Since it is not having any importance, it is not considered. If it is having importance, means it will be considered, right? So indirectly, which is having a very low information gain, which is having the high information gain, that we are going to use in the decision node, which is having the low information gain, that we are not going to use in the decision node. Means that is not having any information. Any information is not there, means that particular variable we can delete. So either you can take in here the discrete variable in terms of information gain, or through bagging or boosting techniques after modeling only. But these all the future importances you can identify only after the modeling, either in the lasso regression also after the modeling only, and bagging and boosting techniques are also after the modeling only. Before to the model, we can't know which is an important variable. We don't know, right? Next, now coming to the next point. If you go to the next point, that is called as wrapper methods. The next type of methods is called as wrapper methods. One is during before modeling, one is after modeling. This is with modeling. This is with modeling. What is with modeling? This is something special. With modeling. With modeling, it will be done. Now, what is with modeling means? For example, let me explain the wrapper methods in a simple way. So, you are doing some kind of cooking. You are doing some kind of cooking and you want to cook the biryani. Assume you want to cook the biryani. For biryani, some ingredients are required. Okay, some ingredients. Whatever the ingredients are required for the biryani, you are going to add one by one. You are not going to add everything at a time. Now, only the masala you are going to add everything at a time. But remaining everything you are going to add one by one. First, initially you may add with respect to starting with the ghee, and you may boil the ghee for certain time. Later, you may add the onions. Later, you'll add the tomatoes. Like this, one by one, you are going to add. And by adding everything, and slowly you're adding the masala for that. Like this, you're adding one by one ingredient. And finally, you're adding the rice. Okay. And finally, you're going to get the final product. That is biryani. So in order to get the final product, you are adding one by one. If somewhere the taste is not good, what you are going to do? You are going to do the modification, right? In the same way, wrapper methods are also same. In the wrapper methods, we are having one called as forward future elimination. Forward future elimination. Second one is called as backward future elimination. Forward future elimination and backward future elimination means you are going to remove one variable and you are going to check how your model is performing. You are adding one variable and checking how the model is performing, and this particular variable is important or not, you are going to work. For example, you are having total 10 columns are there. Okay, first you are going to start only with one variable. Only one variable, which is having a very high correlation. That one variable only you are going to select. And second, you are adding the two variables. And now you are going to see the how the model performance is there. Now you are adding one more variable, how the model performance is there. Adding one more variable, how the performance is there. Adding one more variable, how the performance is there. Means while cooking the biryani, how you are adding one gradient and you are tasting and you are cooking again, cooking, and you are cooking now. Then how we are going to do that process? For example, first time you are cooking some particular product, first time, forget about the biryani. Take one more example, different example. You are cooking for the first time. Okay. How it is going to taste, you also don't know. By seeing, you have seen some video in the YouTube, or you have seen something in the paper, and based on that, you are ready and you want to cook, right? So first you are adding some first ingredient, two ingredients or three ingredients. First you'll taste that one. Salt is sufficient, or should I add the salt or something, you are checking. And if the salt is very low, what you are going to do? You are going to add some more salt. After that, you'll add one more ingredient, separate ingredient. Again, you'll do the some part time for cooking. Again, you'll check the taste. Up to here, it is nice or not. Again, you'll add some more ingredient. Again, you'll check the taste. Every time you are going to check the taste till the final time. In between, multiple times you are going to check the taste. Now, the same thing is called as future forward elimination. Means one by one variable you are going to add, and you are going to check how the model performance is there every time. First, take one variable and see how the performance is there. Try with one more variable, how the performance is there. Try with one more variable, how the performance is there. Like this, you are going to add one by one. If you are doing that one in the forward direction, means it is called as forward future elimination. If you are doing in the backward, means it is called as backward future elimination. Right? So this we can do when we are having a limited number of variables. In which scenario we are going to apply this one? When we are having a limited number of variables, and if this particular variable, if someone says that it is important, and we also feeling that it's important, now whether if I add this one, what happens? If I remove this one, what happens? If you want to cross verify, in that case, we are going to do this one. There'll be some projects in some situations. Every project will not be of same, right? So in some situations, we may get, some people will say that, sir, for this particular column, for this particular project, if I add this one also, it will be an added advantage only. Let us try. If I add means what happens? If I delete means what happens? So in that case, we are going to use the wrapper methods, right? So all the methods and everything we are not going to apply in every case. For example, we are having the mean or median. Missing values you have to fill with mean or median. Which one you are going to use? Means that depends on the data. And outliers are there. How you are going to treat the outliers means again that depends upon the project. First, you are going to identify the outliers data separately. And if you are having more number of outliers, you'll identify what is the reason behind that. If you are having only one outlier, means that is not a problem. You can delete also. That is not a problem. But if you are having more amount of outliers, for example, Flipkart sales are there. If I'm working on the Flipkart sales, I'm saying with one of the example. Every example will not be the same. Every project is not the same. I'm saying one of the example, right? In the Flipkart sales, obviously some of the Flipkart in the entire year, 365 days. If I take the entire year daily sales data, in that some of the records will be outliers. Not one record or two records, at least 30 to 40 records will be outliers. Okay. Now, if I observe that 30 to 40 records, now if I extract the data separately, every record is during the offer time. During some offers will be there. Every month we'll have at least 1 or 2 days offer. Okay. Starting days means salary days sale they'll keep. Ending means month end sales they'll keep. Some name they'll create the sales name and they'll sell finally. Okay. Finally, they'll create the sale name, some name. And they're going to bring with respect to some kind of offers, and using that offers, they are selling the products. Right. So now this in this entire context, whatever we are having, if you observe this outliers, you are having more than 40 days will be outliers. Now, what we are going to do this? In this case, what we have to do? We can't replace the values, right? They are already original data. The sales are original data. We can't replace. Then what we have to do means we have to keep them and we have to train the model. Okay. In that case, we have to retrain. We can't do that with respect to replacement. We can't remove also. In that case, we have to do the retrain. Right? Now, retrain, how we can do? Sir, if I retrain that one, linear regression is going to impact with the outliers now, because the entire model is dependent on the X bar. X bar is impacted with the outliers. Mean is impacted with the outliers. If mean is impacted means automatically linear regression will be impacted. Linear regression impacts means automatically lasso regression will be impacted. All these are impacts now. Then how we can do? In that case, now you take the data, whichever the outliers data is there, that one you keep separately. You keep the 40 days separately. Out of 365 days, I'm having overall 365 days. Okay, let us take like this. I'm having overall 365 days. Out of 365 days, 40 days, 40 records are having outliers. That too, right side only outliers are there, not left side. No left side outlier is there. Everything is only towards the right side because more cells are there. Okay, whenever there is a more cells, this is outlier data. Now I have observed the data. If I observe the data, in the data, I have observed all the data is having the common name called as offer, 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 offer. Means on offer day, it is working, it is giving more cells. Next, then what I'm going to do? I'm going to separate the data. I'll separate the data like this. How I'm going to separate the data? Means out of 365 days, I'm going to separate the data 325 days of one, 40 days of one data set. This is one data set. This is one data set. For example, if you asked me to predict on any particular day, what would be the sales means? If it is offer day means, I will use this data set. If it is a non-offer day means, I will use this data set. This is one way of approach. Whether this approach is correct or wrong, till I do that work, I don't know. Till I do that work, I don't know. This approach is 100% correct, I can't say. Till I do that work, I don't know, because I'm having some train data, test data also, right? Everything I'm having train and test. I'm not working on entire 40 records of one model only, and I'm going to say that this is the answer. I'm not saying like that, right? In this 40 days, I'm going to separate some records for testing purpose. So I'll train the model. And if you are giving any unknown data for me, first I'll check whether that unknown data is a offer day data or non-offer day data. If it is a offer day miss, then I'm going to apply this model. If it is a non-offer day miss, I'm going to apply this model. I have created two different models, separately. And in the deployment also, I'll write like this. If the day is equal to offer, apply this particular model. Whatever the model is there, this model number 1. Else, elif. Instead of else, elif. If the day is equal to offer day, some offer day is there. Okay, if it is non-offer day, model 1. If it is equal to offer day, model 2. And I'm going to use this model, and based on that model, I'm going to predict. Instead of using for both of them a single model, I will create two different models. For offer days, one model. For non-offer days, one model. General days, one model. I will check whether it is working in this way or not. Second way is I will combine everything and I will retrain the data. Means I will keep entire things and I will try. Instead of applying the linear regression or lasso regression wherever it is going to impact by the outliers, that algorithms I will remove. I will try only with the outlier which is not having any impact. That is XGBoost or gradient boost. These are all not having any impact on the outliers. So I'm going to use those algorithms, and using those algorithms, I'm going to predict. I will check that one. I will check this one. Finally, my requirement is to get the maximum accuracy. That is my requirement. So in order to get that maximum accuracy, I will try all the options, whatever I am having. Is that clear, guys? Data pre-processing is completed. Once the data pre-processing is completed, modeling, how much time it will take for me? And that too, for one model only, I have to create everything. First time only, I have to create for each model, default model, hyperparameter, and this one. But once the entire code is ready with me, for every data set, the same code only, now copy paste only, right? Extrain, fit on extrain, Y-train is fixed. Default model is fixed. Everything is fixed. Hyperparameter tuning values are fixed. Nothing is going to change, right? How much time it will take to apply for a one model? It only takes the processing time. For you, nothing. For you, it is going to take only hardly 2 minutes or 3 minutes of time for each model. The only is how much time the Python will try do that one. It is going to depend only that one. If it is a small data set, miss, immediately, instantly you will get the answer. If it is a large amount of data set, miss, Python will do the processing and you will get the answer in 5-10 minutes or 15 minutes. Okay, it's depend only on the Python processing speed. Remaining everything is common. Once for one project, you have created the entire code from starting to ending, miss, just you have to change the data set only, right? Remaining everything is constant. And finally, whichever the model is good, that one model you are going to use for prediction and you are going to submit the answer. Is that clear, guys? So this is the way of doing the future selection. So these are the various techniques which are available for the future selection. And the same thing I have written in the PPT, and I'm going to upload this PPT also. Anyways, you already know the code, entire codes for everything. So I have no need of any code separately for this. So for continuous variable, we are going to work on the correlation coefficient and variable variance threshold. Variance threshold means nothing but which is having the low variance. Okay, threshold means some value. You are fixing some value. And mean absolute difference, mean square difference or mean absolute difference, both. Okay, either of. Next, for discrete variable, you are going to take the information gain, and you can even apply the chi-square test also. If the chi-square test says that these both are having the same thing, based on the chi-square test p-value, you can decide whether this is a good one or a bad one. Now, why chi-square test, sir? Why? What is the use of chi-square test? Chi-square test and chi-square test and one proportion test both are same. How many of you know this both are same? One proportion test and chi-square test both are same basically. If you give one variable means it is one proportion test. If you give two variables means it is chi-square test. Right? For discrete variable, only one test is available basically. We have worked separately one proportion test, that is binomial test. Binom test, I have applied that one and I have shown you the example. But basically chi-square test and one proportion test both are same. If you give inside the chi-square test one variable, the same answer you'll get. If you give two variables also, you'll get the same answer. If you give the three variables also, same. Okay, means for example, let us take like this. You are having only one column. The column is gender. In that you are having male, female, male, female, male, 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 male. Something you are having like this. Basically, when you are having a single column, what test you have to apply? What test you have to apply? One proportion test you have to apply. Instead of applying one proportion test, you apply the chi-square test. Okay, apply one proportion test for this and see the p-value. Apply one proportion test and see the p-value. Apply the chi-square test and see the p-value. Both the answers will be the same. Both the answers will be the same. Just try. After the class, you take one variable of your choice, gender column, and create with respect to males and females. Okay, take at least 20 to 30 records of randomly of your choice. Write how many males you want to write, how many females you want to write, and just apply the one proportion test first and see what is the answer. And after that, you apply the chi-square test and see what is the answer. And both the answers will be the same. Right? Now, here, just a chi-square test means nothing but you are applying the one proportion test only. And you are going to get the answer. So these are called as filter methods. These all of them are applied before to the train only. Train test split only you have to do all these things. Means before to the modeling only you have to do all these things. Okay. That is, these are all comes under EDA. Part of the EDA. While observing the exploratory data analysis, EDA you are doing when you are observing the data, at the time itself you'll observe all these things, and at the time itself you'll write that whichever the variable is having low correlation, you'll take a note of that. During the data cleaning process, you'll remove that one. In the EDA, you'll observe everything. Every variable you'll observe in the EDA, during the EDA, which is having a low correlation, which is having low variance, which is having low information gain. All these things you are observing in the EDA. Okay. Next, wrapper methods. Coming to the wrapper methods, we are having forward future elimination, backward future elimination, and recursive future elimination. Okay. Recursive means nothing but a random subset. Randomly it is going to choose random subset of eliminations. Right? Next one is lasso regression, bagging, and boosting. These three of them comes under embedded. This will be done only after the modeling. Okay. Model will tell which features are important. Model will tell which features are unimportant. Is that clear, guys? Done. So that is with respect to called as future selection techniques. The next one we are having called as future extraction. This is future selection. The next one is future extraction. That is TCA. Future extraction is nothing but TCA. principal component analysis. Using this technique also, we can remove the unimportant variables. Okay. Using the PCA also, we can remove the unimportant variables. PCA is called as future extraction method. Future extraction. Right? Now, okay. So now you are doing the future extraction, that is PCA. Now, when we are going to use the PCM is when we are having the high dimensional data, that is more number of input columns are there, then automatically it increases the computational time and makes the data pre-processing or EDI, everything more convoluted. Means it will take more time. Okay, it is going to disturb more. And now, in order now by using the PCA, what is PCM is? PCA is a dimension reduction technique that enables you to identify the correlations and patterns in the data set, and it will be transformed. Here, this word is there, right? This word is important. And it will be transformed into a data set of significantly low dimension without loss of any important information. It is going to transform, means the original data is not going to be there. Now it is going to transform to the new data. The entire data will be changed. Data will be changed. It is going to transform to the completely new data. Transformation will be done. The original data will not be there, right? This is one of the most important, guys. So here it identifies the patterns and correlations. Everything was completed. It will be transformed into a new data set. It will be transformed into a convert. So when you are doing the future scaling, whether the old column will be there, old values will be there? No, new values will be there. When you are doing the future transformations like log transformation, or you are applying the square root transformation, old values will be there? No, completely new values will be there. So it is going to transform into completely a new values. The old values completely will be erased, and it is going to create a new set of values, and which is having a low dimension without losing any important information. Sir, what is the meaning of this and how it is different from the future selection? So let us understand with a small example. Okay, in a company, total 10 people are working. In a company, 10 people are working. Out of these 10 people, assume that this is your company. Okay, your company. In your company, 10 people are working. Example, take a small example. In your company, 10 people are working. Now, you are not having the enough money to pay the salaries for all the 10 people. Okay, you are not getting the new projects due to the some kind of recession or something reason. You are not able to get a new projects for your company. Since you are not getting a new projects, the circulation of the money is not there. So you want to remove some of the people. Some people you want to remove. How many people you want to remove is, let us assume you want to remove one person. One person. You can't pay for 10 people. You can pay only for 9 people. You want to remove one person. Now, which person you are going to remove? Okay. Out of 10 people, you have to remove one person. Out of 10, remove one person. Now you are going to identify which person is having the low stuff, means he is not having that much of knowledge, or he has not regained any new skills in recent times. You are identifying, because out of 10 you want to compare. Out of 10 you want to compare. So when you are doing the comparison, when others are moving very fastly, you are not moving that much of fastly, automatically they are going to remove you. For example, in your company, 10 people are there. 10 people are talented only. Because they are talented only, you have hired. Otherwise, why you will have? First thing only, that is the main thing. Okay. First, you have hired 10 people. That why you have hired 10 people? Because you have felt they are having the talent and they can do the project. That is the reason you have hired. Okay. Initial talent, based on the initial talent, whatever the talent they are having, you have hired the 10 people. Keep this one aside. Based on the initial talent. Completed. Initially, they are having a very good talent. Initially, you are also having the budget with you. Initially, budget is there. Initially, you are having the projects with you. Multiple projects are there. So since you are having the projects with you and budget is there with you and you are getting the money from outside, so that money you are giving for the people as the salaries and you are maintaining the company. But suddenly some projects was dropped. This is not initial. After certain period of time, now there is no projects, no new projects are not coming for you. No more new projects. What are the existing projects are there that you are going to complete, but no more new projects. Now you have to remove one of the person. Now all of them initially are talented only, you have hired initially. Now after certain time, let us assume after 6 months. Now after 6 months, you have to remove one of the person. Now what you are going to check? Still you are going to depend on the initial talent only, yeah? No, right? Now latest talent you are going to depend. Not with initial talent, right? 2 years back you are having extraordinary talent. Now what is your talent? Now, tell me now, not initial one. So company always wants their employees to upskill themselves every time. Why I'm saying this example means tomorrow in the company, you also have to upskill yourself. What are the initial talent you are having and you have got as a data scientist role means once you enter into the company, again, you have to upskill yourself, learn every day something, skill yourself. If you are, once you get the job, you are saturated and you are keeping the same knowledge forever means your salary also will be forever same. It will also not increase. If you want more salary means your skill has to increase. As more skills are there, more salary you'll get. Simple. Now, after 6 months, now you want to remove one of the person. Now, what you are going to do? You are identifying the talent of the 9 people separately. I mean, 10 people separately. And which person is having now presently, which person is having the low talent, that particular person you are going to remove. Okay. For example, 2 persons are having equal talent. Both of them are having the equal talent and exactly the same. Everything is same. Now, what you are going to see? Salary. Okay. For example, these both of them are having same to same talent. Both of them equal to equal, neck to neck. Communication skills wise same, everything same. No difference. Not even minute difference also is there. And both are equal important for you. You can't say this person is more important for my project, this person is more important. Both are equal important, but still you have to remove one person. Now, what is the option for you then? Salary only. This person you are paying 6 lakhs, this person you are paying 5.5 lakhs means just you are going to remove this person, at least to save the 50,000. If this person is your friend, then you might keep. But if there is no bias, assume you are eliminating the bias. If there is no bias means generally the company people will see like this. First, they will see the present talent. After present talent, second, they will see with respect to the salary. Second option, salary. Okay. For example, bias is there means, for example, they are friends or they're close relatives or they're close with HRs. Then we can't do anything. In that case, we can't do anything. These all of them are nothing. Simply it is based on the reference or something. Then we can't apply this logic for that. Right? In that case, we can't apply this logic. But generally, who are having a good talent, out of 10 people, we are identifying the 9 people and we are going to remove. We are going to remove one person who has low talent comparatively low. Basically, he is also having talent, but when compared to these 10, he is low. When compared to outsiders, he is having a good talent. That is the reason he has worked 6 months in that company, right? Now, here he is having a low talent and you have removed him. This is called as future selection technique. Earlier, whatever we have discussed, the filter methods or embedded methods or everything, directly we identified which are the important features, which are not important, and simply we have removed. This is called as this one. Now, future extraction method. Now, the same question, same to same. I'm not going to change the example. If this is, we are applying the future extraction technique on the same example, what happens means, for example, this person, you want to remove this person. But this person also will have some talent, right? Compared to low talent is there, but some talent is there. Whatever the talent he is having, we have to utilize him. Before removing him, we have to utilize him. How we can utilize him? Means by knowledge transfer. Means we'll ask him to share his knowledge to the others. Now, directly, if you ask in the company, hey, oh, you are having a very good knowledge now, please share to others also, means none of them will share in the companies. In real time, none of them will share directly. Only trainers will share their knowledge to the students. But in the company, none of them is going to share like that. Right? Now, in the companies, whatever the knowledge you are having, you are not going to share the knowledge to your colleagues. Now, what they'll ask means, indirectly they'll ask you. What they'll ask means, by conducting some kind of webinars on a particular topic, they've selected some topic and they'll make some kind of webinar and they'll ask this particular person to give the webinar. Now, in the webinar or in the seminars, obviously he will expose something and he will give something, right? Now, whatever his talent is there, now his talent, you are transferring this one to the other variables. Whatever his talent is there, you are transforming his talent to other variables. Basically, assume that you are very good at regression. You are very good at classification, but you are weak at EDA. You are weak, assume. Now, someone has transferred who is very good at EDA. I'm asking that particular person to transfer his knowledge to you. Now, the knowledge is there. At the same time, this person will not be there. I'm going to remove. What is this technique is called? Means use and throw technique. First, we are going to use him. Later, we'll throw him. Called as use and throw. Right? In real life, we'll use and throw, right? So in the same way, just we are going to use. First, how we are going to use means we are going to ask his entire subject to be shared. His entire subject will be shared to the other persons. Instead of sharing to a single person, I'll ask to share to the entire team. Okay, in a team, these many people are there. Okay, let us take an example like this. I'm having certain persons and one X person. One X person is very good at EDA. And I'm asking this person talent to be shared to the others. Basically, others are not having, basically before to this webinar, they are not having that knowledge. But after the webinar, they have gained the knowledge. Means they have transformed. Initially, the data is different. Now the data is different. What the point? Whatever the knowledge is before to the same person, before some knowledge is there, after transforming his data to him, now the new variable, it has been converted to a new variable. Point is clear? This point is clear. Mostly this is important. Now this, whatever we are having, this is a new one will be transformed to all the variables. Now, once we have transformed this one to all the variables, now everyone has learned from him. And now we are going to remove him. Now, without losing any important information, we are transforming the data. It's called as PCA. Now it is clear. So it is transformed into a new data with low dimension. Means we are going to remove that particular variable without losing any important information. Because that information already shared to the others, right? That information was shared to the others. Is that clear? Now, okay, sir, this concept theoretically, whatever you have told in that example, it is working. But how in the Python it will work? I mean, how in the statistics or maths, how it is going to transform? Means whether they are going to explain, no, right? How it is going to transform is there is a concept called as covariance. There is a concept called as covariance. Using that concept, we are going to work. Now, if you observe here I'm having two variables, variable N1 and variable 2. This is the scatter plot. If you observe the scatter plot, this distance, whatever the distance of this one is there, this entire distance is future to distance, starting from here to ending here. And it is having some variance within that. Okay. And future one is having certain variance. Means assume there are two columns are there, Amma. Two columns are there, column 1 and column 2. Okay, let me take like this. Still more very clearly. Let me try. Just let me try with one more example. So in the classification, earlier we have worked on the KNN classifier. We have taken one data set. In that data set, I'm having two input variables. Okay, I'm having two input variables and I have applied the scatter plot like this, right? Now, once again, let me execute this one. Okay, and I'm applying the scatter plot, but without the hue, without using the hue. I know I don't require the hue, only this one. Now you are having the scatter plot like this. Is the scatter plot is clear? Some scatter plot. Okay, how you got this scatter plot means based on the two input variables x1 and x2. Okay, now here you are having some scatter plot. Now in this scatter plot, you are having the Jenny 1 and Jenny 2. Now Jenny 2 starts from here, Jenny 2 ends here. Now this is having certain variance. Jenny 1 will have starting from here to ending here. This is also having certain variance. Both of them are having the variances. Now what is meant by variance? Variance means the data point, how much it is from the center. Okay, distance from the center, how much it has varied from the mean is called as variance. So now this particular Jenny 2 is having certain variance and Jenny 1 is having the certain variance, means x1 variable is having certain variance and x2 variable is having certain variance, right? Now the same thing here, just in this also I have taken the same x1 variable and x2 variable. This is having certain variance and this is having certain variance. Now what I'm going to do, I'm going to transform this data into everything to the one variable. Means I'm doing some kind of projection. Okay, by doing some kind of projection. Now what happened? Here in this variable, I have projected all the data points on the x-axis. I have projected. Now what happened? Suddenly in this future, the variance has increased. The variance of this one has been decreased. The variance of this one has increased and the variance of this one has been decreased. And which is having the low variance, that variable you can delete, right? Which is having a low variance, that variable you can delete, right? There is no variance means you can delete that variable. So now how we have got this one? By applying the orthogonal projection. By doing the projection. Okay, by doing the projection, I have converted from one to another one. So earlier, one example I have told you is company example. In the company, 10 people are there and where you are asking one of the person to share his knowledge to others and you are going to transform the data. This is one way. This is one more example. This is also an example. This is also an example. I'm saying example, how this variance will be reduced of the one of the variable without changing the data points, just by changing the projection. Initially, you are having a normal projection. Now you have changed that one to orthogonal projection. Right? Now, let us see in PCA how it is going to work. First, you are going to do the standardization of the data. The steps involved is first standardization of the data. After standardization of the data, you are going to create a covariance matrix. You are going to create a covariance. Now, covariance word is more important. Now, what is the meaning of covariance? Variation of one variable explained by the another variable. That is called as covariance. Now, you are going to use the covariance matrix. And from the covariance matrix, you are going to identify the eigenvalues and eigenvectors. Now, what is eigenvalues and eigenvectors and how we can calculate everything we are going to see. Now, from eigenvalues and eigenvectors, from that we are going to identify the principal components. And once we identify the principal components, which component is total of cumulative is 0.95, that one we are going to select, and which are more less than 0.5, we are going to remove less than 0.05. Is that clear? So let us do one by one, step by step. Let me explain. Let us consider a sample data set. In that sample data set, I'm having a data set like this, where maths, English, and arts marks of the 5 students are there. Total, how many input columns are there now? 3 input columns, x1, x2, and x3. And this dimension reduction is applied only on the input columns, not on the output column. This concept is applied only on the input in order to reduce the number of input features. Now I'm having the 3 columns. For this, first I'm going to do the standardization. What is meant by standardization means x minus x bar divided by standard deviation. So I'm going to first calculate the mean value and standard deviation value, and each value I'm going to do x minus mu divided by sigma. And I'm going to convert like this. This is first step, standardize the data points. Once standardization is completed, second step, you are going to calculate the covariance matrix. You are going to calculate the covariance. Now in the covariance matrix, now what is covariance matrix means? Covariance matrix. This we have discussed in the statistics. Covariance matrix. Now what is meant by covariance matrix? We are having a matrix where this is the covariance of x comma x, covariance of x comma y. This is x, y, and z. 3 variables are there, x, y, z. And this is the covariance of x comma z. This is the covariance of y comma x, covariance of y comma y, covariance of y comma z. Next, covariance of z comma y, covariance of z comma x, z comma x, z comma y, covariance of z comma z. Okay. Now, what is meant by covariance of x comma x means it is nothing but variance of x, which is nothing but equal to variance of x. X comma x means covariance variance of x. Now, what is meant by covariance of y comma y means which is nothing but variance of y. And what is the covariance of z comma z means it is nothing but covariance of z, which is equal to variance of z. Variance of z. Now, I'm having with respect to the covariance, whatever this value and this value both are same. Covariance of x comma y and covariance of y comma x. Covariance of x comma z and covariance of z comma x also same. Covariance of y comma z and covariance of z comma y also same. So the diagonal matrix, the diagonal values, whatever the diagonal values are there, the diagonal values are going to be the variances value, and upper triangle and lower triangle is going to be the same. Upper triangle matrix and lower triangle matrix will be the same. And how to calculate the covariance also we have discussed in the statistics, and I have shown you the example also how to calculate. Covariance formula is given by first variance. Variance means x minus x bar whole square divided by n minus 1. This is variance formula. Covariance is instead of considering x minus x bar into again x minus x bar, you have to consider y minus y bar. The second variable you have to take. If you take both of them as a single variable, then it is called as variance. If you take two different variables, then it is called as covariance. Right? So this we have discussed in the statistics, and I have told you the difference between them. Now here I'm going to do the covariance matrix. I'm going to calculate the covariance matrix. Now whatever the covariance matrix is there, okay, whatever the covariance matrix is there, if you observe this covariance matrix, okay, if you observe this covariance matrix, basically this covariance matrix is also 3 by 3. Why 3 by 3? Because you are having 3 input features. Since you are having the 3 input features x, y, z, x, y, z. For example, you are having 4 input features. Then what is the matrix you are going to get? 4 by 4. If you are having 5 by 5. If you are having 6 input features, 6 by 6. If you are having 7 by 7. If you are having 8 by 8. 9 means 9 by 9, like this. But you are going to get a square matrix only as the output. Always you'll get the square matrix only. Irrespective of number of records. We are focusing only on the number of columns, not on the records. If you're having 10 records also, covariance is going to be calculated in the same way. Okay, based on the records, if 10, 20 records are there, means covariance, you are not going to get 20 values. You'll get only one covariance value only, right? So irrespective of records, the number of columns, if you are having 3 columns, means 3 by 3 covariance matrix. 4 columns means 4 by 4 covariance matrix. Now, once covariance matrix is calculated, from that you are going to calculate the eigenvalue. From that, you are going to calculate eigenvalue. How to calculate eigenvalue? Very simple. For example, I'm having 2 columns are there. Assume there are 2 columns, X and Y. Only 2 input variables are there. Now, what is the covariance matrix I'm going to get? What is the matrix I'm going to get? 2 by 2 matrix. That is X, Y, X, Y. This is covariance of X comma X. Covariance of X comma Y. This is covariance of Y comma X. And this is the covariance of Y comma Y. I'm going to get only 2 by 2 matrix. Total 4 values will be there. Out of 4 values, these both will be the same. And these both are variance of the X, variance of the Y, separate. Now, here I'm having the total 4 values. For these 4 values, whatever the 4 values are there, that is 2 by 2 matrix, I'm going to apply det of A minus lambda I. A minus lambda I. Det of A minus lambda I is equal to 0, where this lambda is the eigenvalue. For example, let us take like this. I have got 4 values like this. The first value of covariance, this is 2. And this is 3. This is 4. And this is 5. I assume I have got the values like this. These both values should be the same now. Covariance of X comma Y and covariance of Y comma X should be the same. And 2 comma 5 and 4, 4. Something I have got like this. Now, this is the covariance matrix. For this, I want to calculate the eigenvalues. How to calculate the eigenvalues means just you are going to take A. This is assume the a matrix A. A minus lambda I. This is A matrix. A is nothing but 2, 4, 4, 5, which is nothing but our covariance matrix. Lambda I. Now, what is meant by lambda I? I means identity matrix, which is 1, 0, 0, 1. Lambda I means you are just multiplying with the lambda value. So what you are going to get? Lambda like this. 1 into lambda is lambda, 0 into lambda is 0, 0 into lambda is 0, and 1 into lambda is lambda. This is lambda. A minus lambda I. A minus lambda I means 2, 4, 4, 5 minus lambda I. Lambda is lambda 0, 0, lambda, which is nothing but 2 minus lambda 4, 4, 5 minus lambda. This is the A minus lambda I matrix. For this A minus lambda I matrix, you are going to calculate the eigenvalues. How to calculate the eigenvalues means just you have to take the det. That is 2 minus lambda, 4, 4, 5 minus lambda. This det should be equal to 0. Now, how to calculate the det? Det is nothing but AD minus BC. That is nothing but just you are going to multiply these 2 values. That is 2 minus lambda into 5 minus lambda minus these 2 values. That is 4 into 4. That is 2 into 5, 10. 2 into minus lambda, minus 2 lambda, minus 5 lambda, plus lambda square, minus 16, which is equal to 0. Now, lambda square minus 7 lambda and 10 minus 16 minus 6, which is equal to 0. And from this, you have to calculate the lambda values. That is lambda square minus 6 lambda minus 1 lambda minus 6 is equal to 0. If you take lambda as the common, lambda minus 6, and if you take the plus 1 as the common, okay, and you are going to get lambda minus 6 is equal to 0. Now, lambda minus 6 into lambda plus 1 is equal to 0. Now what are the lambda values? One is 6 and one is minus 1. Right? You know how to solve the quadratic equation, right? Just I'm solving the quadratic equation and I'm getting the lambda values, nothing else. Is that clear? How to calculate the eigenvalues? This is called as calculation of the eigenvalues. Okay. Now, how to calculate the eigenvalues for a matrix? In your notes, please write how calculation of eigenvalues, of a matrix. How to calculate eigenvalues of a matrix? That is nothing but depth of A minus lambda I is equal to 0. Depth of A minus lambda I is equal to 0. Means here, whatever the A is there, A is nothing but your covariance matrix. A is your covariance matrix, where lambda is nothing but your eigenvalues. A is covariance matrix and I is lambda eigenvalues. For example, you have got a covariance matrix 2, 4, 4, 5, something like this. Means this is your covariance matrix. Assume this is your covariance example. Take an example like this, heading as example, and this is equal to your covariance matrix. In that case, you are going to apply just 2 minus lambda, 4, 4, and 5 minus lambda is equal to 0. That's it. Just you have to add for the diagonal values minus lambda, minus lambda, minus lambda, you have to add. For example, you are having something like this: 2, 4, 5, 4, 9, 6, 5, 6, 7. Something you are having like this. A matrix is like this. This is the covariance matrix, where upper triangle and lower triangle should be the same, and diagonal values should be the variances values. And you have got this is the covariance matrix. If this is the covariance matrix, then what you are going to do? 2 minus lambda, 4, 5, 4, 9 minus lambda, 6, 5, 6, 7 minus lambda. Depth, det is equal to 0. Det is equal to 0. And we know already how to calculate the det. Okay, any matrix, how to calculate the determinant. How to calculate a determinant. Since I'm having the 3 lambdas like this, I'm going to get an equation called as lambda cube. Whenever I get the lambda cube, automatically how many lambda values I'm going to get? 3 lambda values I will get. If lambda square is the equation, then how many lambda values I'm going to get? 2 lambda values. In this case, I'm going to get 2 lambda values. 2 lambda values. In this case, I'm going to get 3 lambda values. Now, miss, what is the meaning of this? How many number of columns are there? That many lambda values you are going to get. 10 columns are there, miss, 10 by 10 matrix, automatically 10 lambda values you are going to get. Lambda means nothing but eigenvalues. If you get 10 means 10, 20 means 20, 30 means 30. Number of columns, how many columns are there? That many eigenvalues you are going to get. In the max, we require the linear algebra concept. That linear algebra is nothing but this one only. If this is clear, in the entire, this is the linear algebra which you require. Nothing more than this. It is sufficient. Is that clear, guys? Now, once this is done, now I'm having the 3. Now for this data set, whatever the data set I'm having here, okay, for this data set, I have applied the eigenvalues. For applying the eigenvalues, what I have done? Minus lambda, minus lambda, minus lambda. And I have applied the determinant over this. Now I have got 3 lambda values. Output as 3 lambda values. Guys, I'm saying detailedly inside what happens. But in the Python, you don't need to do anything manually. Don't worry. You don't need to take pen and paper and you don't need to do any manual calculations. Not that much of max is not required in real life. Just I'm explaining how it will work. Because blindly, I can't explain the coding part. I can't explain the coding part directly and how it works. I will explain detailedly how it works in the back end. What is the fit is then inside that. I will explain like that. Right? Now, once it has calculated the lambda values, now what are the lambda values it has got, miss? The lambda values are, first one is lambda 1 is equal to 1.899 is the first lambda value. Second lambda value is 0.0501. Third lambda value is 0.7493. First, it is calculated 3 lambda values like this. Now, after calculating the 3 lambda values now like this, now you are seeing what is the percentage of contribution of lambda 1, percentage contribution of lambda 2, contribution of lambda 3. Now I want individually percentage. Now how to calculate individual percentage means lambda 1 divided by lambda 1 plus lambda 2 plus lambda 3. First I will calculate the total. Within the total, how much of lambda 1 value is having. Separately, I'm going to calculate for lambda 2 within the total. Again, I'm going to calculate lambda 3 divided by lambda 1 plus lambda 2 plus lambda 3. Now, if I calculate this one, first I'm going to calculate the total. I'm opening the calculator. And in the calculator, I'm going to do this one, calculations. Okay. So first one is, that is first I'm going to do the total. Total is 1.899 plus 0.0501 plus 0.7493. Okay. What is the total miss? The total is equal to 2.6984. The total is 2.6984. Now, first one, let us see the first one. That is 1.899 divided by 2.6984. What is the one miss? 70.3%. 1.899 divided by this one is 70.3%. This is having 70% weightage. Lambda 1 is having 70% weightage. Now, lambda 2, that is 0.0501 divided by 2.6984. And this is having 0.018, which is equal to 1.8% into 100. If you are multiplying into 100, I will get the percent. Right? Now, later, the third one. That is, what is the third value? 0.7493 divided by 2.6984. And this is having 27.76%. Okay, I'm having like this. Now, this is having 70% contribution. This is having this much of contribution. This is having this much of contribution. 3 contributions. Weightages I'm having. Contribution means nothing but weightage. Their weightages. Now, out of the weightage, now if you see this, first keep everything in the sequential order. 70.3. Okay, weightage. First, next 27.7. Second one. Next 1.8. Now, if I add these two, what is the weightage of these two? Which is almost close to 98%. This is having 2% weightage, or it is 100% of weightage. Out of these two columns only contributing 98% weightage. So I'm going to drop this column. So like that, first, for example, I'm having total 10 columns are there. Assume like this, I'm having 10 columns. 10 lambda values are there. 10 lambda 1, lambda 2, lambda 3, lambda 4, lambda 5, lambda 6, lambda 7, lambda 8, lambda 9, and lambda 10. Okay, total 10 lambda values are there. For 10 lambda values, first I will calculate their weightages. First, what I will do? First, I will calculate the weightage. What is their weightage? Now, how to calculate the weightage of each eigenvalue? How to calculate the weightage of each eigenvalue is by doing that particular lambda divided by total, sum of the lambda values. Each lambda value divided by total lambda values you have to do. Right? Then you will get the weightage. After doing the weightage, now I'm going to keep them in the descending order. In the descending order. What is meant by descending order? High to low. I'm going to keep them in the high to low. Okay. Now, high to low, I'm going to keep all the 10 values. Now, first, I'm going to do with respect. First, I will combine these two. What is the total? Next, I will combine these. Like this, I'm going to add 1 by 1, 1 by 1, 1 by 1, 1 by 1. Wherever the total I'm getting more than 95%, I'll stop there only, and remaining all the columns I'll delete. I want which has the total weightage of 95%. And I'm going to delete. Okay. Let me show you the coding part. Of course, I'm not going to explain the entire coding part now because already time is 7:30. If I start means it is waste of time. So the coding part we'll see in the tomorrow's class, but just I'll give a overview so that you'll have a good clarity on that. Okay. Now, so see, just observe this one. Okay, I'm going to consider one data set. Where is the data set? I'm going to import pandas as PD, and I'm going to take one wine data set where I'm having total 14 columns are there. Total 14 columns, out of which 13 input columns and one output column. I'm having 13 input columns and one output column. Now these 13 columns I want to reduce. I want to reduce these 13 columns. Now just if I apply this logic, just observe this one. By applying the PCA, if I apply the PCA, first I'm going to do the standardization. Okay, I'm applying the PCA and I'm applying the standardization. After applying the standardization, here I'm writing with respect to 0.95. 95 means which contributes the 95. Now I'm going to get only with respect to 10 columns as the output. You can see here 10 columns. Instead of 13 columns as the input, you can see only 10. If you write here with respect to 1, now you can see all the 13 columns with respect to which is having a 0.99 something. Okay, all the 13 columns. This is the each of the column, their corresponding weightages. 13 columns weightages. Now, just first you calculate the first one. Open the calculator. And first you calculate the first weightage. What is the first weightage? 0.3688. First one. Plus second one weightage 0.1931. What is the total you have got? 56, almost 56, which is not equal to 95. But now if you add with respect to third one is 1075. Now what is the weightage? 66%. By adding 3 columns, 66% you have got. Now let us try like this. I'm asking for, I required only 66%. For 66%, how many columns I require? 3 columns are sufficient. So it is going to give me only 3 columns. Is that clear now? If my requirement is 66 means it is going to give me only 3 columns. For example, I ask only 50%. For getting 50%, how many columns I require? First column will give 36% only. It will not give the 50. At least I have to add second column also. Then only I will get the 50% weightage. So if I want 50% weightage, minimum I have to consider 2 columns. Is that clear now? Similarly, if I want a 95% weightage, till I get the 95% weightage means I have to take 10 columns. 10 columns only contribute the 95%. So remaining 3 columns are not important and you can remove that. Is that clear? That is with respect to PCA. PCA will reduce the number of input dimensions. At the same time, information will be stored. Is that clear? So the coding part we are going to see in the tomorrow's class. Okay, first we'll start the coding part in the tomorrow's class and then I'll explain the PCA. And from that, we'll continue with the remaining, whatever the next topic, whatever the topic is there. Clear, guys? Any questions? Clear? So just to give me a minute, I'm uploading the notes, entire notes. As one of the student is saying, please upload the STS notes. I already have uploaded STS notes. No. Ada Boost. Oh, only Ada Boost. Okay, just give me a minute. I'm just uploading now itself. Google Drive in that classification. Ada Boost. Okay. Gray Ada Boost. and the boosting nodes. Yeah, nodes. Just open that drive. Everyone, please open the drive once. Yes, I have uploaded the nodes. In that, just open the PDF. There is a PDF called as 7, 8, 9, which is the boosting complete. All the boosting nodes is there in that only. That is ADA boost, gradient boost, and exit boost. All the boosting, three boostings will be in the single one. Okay. And whereas coding part is separate. ADA boost, gradient boost, and exit boost. And the data set is Penguin data set. That also I have uploaded. Okay. And next, coming to the today's class, I'm going to create a new folder called as future selection. And in the future selection, I'm going to upload the future selection techniques. Future selection techniques. Okay. And one more folder I'm going to add, that is called as dimension reduction. That is PCA. One more folder, PCA. Separately, I'm adding PCA. And within the PCA, I'm uploading the notes related to PCA. That is today's class PCA notes and coding part also. Yes, everything was uploaded. Please check one by one. Okay, folder number 8. Folder number 8 is future selection. Folder number 9 is with respect to PCA. That is future extraction. One is future selection and one is future extraction. Right, guys? Completely I have uploaded everything. Done. Any questions? Yes. Yes, there'll be no difference between that one because the Jenny impurity, whatever the probability is there, though it is scaled also, the probability will remain same now. Just instead of decision tree, just you take one data set. Randomly you write one example in the notes, some values. You write some values randomly, 5 to 6 values in the notes. And do the scaling. Tell me what is the probability before and what is the probability after. For example, you have taken the values like this, 1, 2, 3, 4, 5. Now I'm asking you, what is the probability of value less than 3? Less than 3 means how many values will be there? Only 2 values will be there. That is 1 and 2. Now do the scaling. Scale the data by divide by 10. Everything you do the scaling. That is 0.1, 0.2, 0.3, 0.4, 0.5. Now you are having 5 values of scaled values. Now the same probability, earlier you asked probability x less than 3. Now the same thing you have to ask x less than 0.3 because that was scaled with divided by 10 means this was also has to be scaled by 10 only, right? So now the probability of less than 0.3, how many values you will have? Again 2 only, 0.1, 0.2. So the before the probability and after the probability is same is Jenny impurities will be the same, decision tree will be the same, accuracy will be the same. Is that clear? Done. So that is the end of the session, guys, and we'll continue in the tomorrow's class.